In chapter 24, we're looking at a number of basically real-world applications. So it becomes a little bit more, on the one hand, it becomes a bit more complicated to understand because some of the assumptions that we made in earlier chapters, like chapter 23, we can't just simply continue on. But we can also use what we've done in chapter 23 to at least set up a couple of ideas that will hopefully make sense. Now, the first of these conceptually sets up other things that are coming. And I wish I could even so much as draw a straight line, but suppose that was a straight line, and suppose I had two lenses, lens 1 and lens 2. Now, at some point, I have an object. Honestly, I don't know what that object is, but that's okay. The lenses don't know either. Is this a physical object? Is it an image projected by something else? Is it a ghost? Who the heck knows? Lens doesn't. Lens just sees it as a thing right here. And so, if I say to, let's see, that lens 1 has focal points given like so, and lens 2 has focal points given like so, then the first step, like normal, is to find where the image of this object created by lens number 1 is, because that's what's going to happen. The light will first go through lens number 1. So I've got one ray through the near focal point that goes out parallel to the optical axis. One ray that goes in parallel to the optical axis. That goes out through the far focal point. And one ray that goes through the center of the lens that's undeflected. And those three rays will converge at the location of the image for the first lens. Now, the image for the first lens becomes the object for the second lens. This is and honestly, it's like, okay, we can envision, this is the simplest case I can envision. So if you just try to copy this each time you see the problem, that will hurt you. But if you follow the reasoning, you won't get hurt. And honestly, you can come up with any sort of complicated system of tossing two lenses around, or have 3, 4, 5, however many you want, and it might look goofy while you're going through the steps, but it'll still work out all right for you. So let's look at this. The image of the first lens is the object for the second. So as before, I've got a ray that goes in parallel to the optical axis, that goes out through the far focal point. I've got a ray that goes in through the near focal point, that comes out parallel to the optical axis. And I've got a ray that, despite how badly drawn that is, as I cheated to make it work the way I knew it would, that will come out through the center of the lens and be undeflected. Okay, honestly, if you do this with a piece of graph paper or even a piece of careful paper where you're using a straight edge and you're careful, this will work much better than my poor freehand art. So you'll still have it, and you'll still be able to find the image. And you can use all the intervening steps that you want to as well. For example, let's see. This is the object distance for the first lens. This is the image distance for the first lens. And the magnification of this object is equal to negative the image distance divided by the object distance. Now, this distance from the image to lens 2 is the object distance for the second lens. And I'm able to use that to find the image distance. So the magnification due to the second lens is equal to negative the image distance divided by the object distance, or, and that's going to be the magnification. This magnification is the magnification of that image, which in itself is a magnification of this image. So the total magnification for the whole system is equal to, well, negative times negative is positive, the object distance of the first lens divided by the image distance of the first lens times the image distance of the first divided by the object distance of the first times the image distance of the second divided by the image distance of the first. Now, this is the easiest system. If I set up one that was different, it would work just as well. Suppose that I have a diverging lens and a converging lens. And I have some image. Let me just see to make sure, see if I need to scan. Oh no, everything still fits on the board. Happy day. So, works the same as it did before. Now for a diverging lens, the three principal rays are set up slightly differently. One goes in parallel to the x-axis, parallel to the optical axis, and comes out on a line through the focal point. One goes in on a line to the far focal point and comes out parallel to the optical axis. And one goes through the center, again, poor lines make up for poor drawing, hopefully, but I'm able to determine an image caused by that first lens. Now, is that a real image? No, it's virtual. I could never form a screen, put a screen here and get an image of that object. But that's okay. This lens has no idea, it doesn't see this lens, it only sees that light as an object. So, I use this object again, or aren't, balancing the fact that, hey, I know the physics work, so if you do this with a piece of graph paper, it will work. And you'll end up with the image for the entire set.